Hello and welcome to this short video about the trapezium rule or the trapezoidal rule. Now we use this when we need to find the area beneath a curve, but we don't know how to integrate it. It doesn't give us an exact answer, but it gives us a very, very good approximation. And when we have a question like this, it's always going to give us a function and tell us how many trapeziums or trapezoids we need to use. So in this particular one, we're trying to find the area beneath 2 to the power x between -1 and 3, using 4 equal trapeziums. The first thing we need to do is fill in a table like this. So I have x values of -1, 0, 1, 2 and 3. Then what I need to do is find the value of f of x. And to keep it exact as possible, I'm just going to have 2 to the -1, 2 to the 0, 2 to the 1, 2 to the 2 and 2 to the 3. You do need to make sure that you look at the exam question carefully. It may ask you to put everything to 3 significant figures, for example. But of course, with this particular question, we don't need to worry. We can do it exactly anyway. We have half, 1, 2, 4, and 8. Now, if I want to find the area of this first trapezium here, first, I think you can see it's going to give us an answer that's slightly too big, because that straight line for the trapezium is going slightly over the curve. I'll do a half times 1 times a half plus 1, which is going to give me 3/4. And I could do the same for each of the trapeziums that I'm using, but there must be a quicker way. If we think about this second trapezium here, and again I think you can hopefully see that the answer is probably going to be slightly too big, because that curve will go underneath that straight line. I'm going to have a half, height is 1 again, the first side is 1 and the second side is 2. This 1 here is the same as this one here. It's this side length. And hopefully you can see that the same would happen on this next one. We're going to use this side here twice. We're going to use this side here twice. We'll use the outer edges just once, this one and this one, because there's not another trapezium next door to it. And this gives rise to the formula we're able to use more quickly. We've got a common factor of a half. We've got a common factor of this one here. Now that's the height of my trapezium. It won't always be 1. So I'm going to have a half times the height of the trapezium plus, times the first plus the last plus 2 of everything else. So in this particular one, it's going to be a half times 1, then a half plus 8 plus 2 of 1 plus 2 plus 4, which gives me 11.25. And then what we'll often be asked to do after we've done that is find the experimental error, or the percentage error. Now the actual this time, you can do it on a calculator or something like that, is 10.82 and a bit. So what we're going to do is 11.25 minus 10.82, and of course we'll actually use the real value from our calculator rather than the approximate 10.82, and that's given me a percentage error of 3.97% to 3 significant figures. Now, the more trapeziums we use, the more accurate our answer is going to be. So if we look at this same question again, but this time we want 8 trapeziums, so I'm going to need to cut each of those trapeziums in half. So we'll set up a table in exactly the same way, x and f of x, but this time we'll go from -1 and then go up in halves instead of in ones. Now I'm just going to finish filling this in without recording it, so you'll see it all appear magically in a sec. So all the numbers are now there, and in the same way as we did before, we're going to use the formula to find the area. So if you remember, it's a half. Now this time, the height of each of these is a half. What you can do is the maximum minus the minimum, so 3 minus -1, divided by however many trapeziums you need, which this time of course is 8. So it'd be a half times a half, first plus last plus 2 of everything else and that comes out at 10.92. So if we look at the percentage error again, 10.92 minus 10.82, and again I'm trying to use the exact values, gives me a percentage error of 0.922%. So as you can see, much more accurate, and the more trapeziums we put in, the more accurate it will be again. So as you want a half of the height of a trapezium. If you remember, that's maximum minus minimum over number of trapeziums or trapezoids. So a half times the height, first plus last plus 2 of everything else. I hope that helps. Thanks very much.